So if I define, here I've got 3 savings accounts that I've initialized with 3 different balances, and suppose I try to put those 3 savings accounts into an array and I try to call sort on that array. So what happens in this case? Does it work because the account balances are numbers and we know how to compare them? Does it not work, but if we added a comparison method, or if we passed a comparison method to the sort method, then it would work? Do we say it doesn't work, but it would work if we define the spaceship operator for savings accounts? Or it doesn't work because since this isn't a basic Ruby type, there's no built-in way to compare them with the operator? So initial vote, I already see some cards even before I finish reading the question. All right, overwhelming votes for red. You guys are on fire today. Let's go through the answers here. Works because account balances get compared. Well, that's certainly what we would like to be the case, but comparing accounts isn't the same as comparing integers, so that's not it. If we passed a comparison method to sort, that's not the Ruby way, right? The Ruby way is sort makes some assumptions about the thing you're trying to sort, in particular that the thing knows how to compare itself to other instances of that thing. So the correct answer is if we define the spaceship operator for savings accounts, and by the way, how would we define it? Well, an easy way would just be to say, as in this example, here's a way to define comparison on bank accounts. Here it is. It's coming now. We have like 2 minutes left. Yes. So here's a way you define comparison on bank accounts. I'm lazy, so I'm just going to define spaceship. And then I'm going to include comparable to get the other ones for free. And in case you don't believe me, I will copy and paste that code. I already had the class account defined, so now, remember I had these accounts with high balances, and I can say, okay? True in so many ways. Okay? So what's the message here? Ruby provides a lot of useful functionality that already do the work you need to do. Your job, it's kind of almost very Zen, right? You need to do the least amount of new work possible to get the functionality you need. When you have behaviors you want to reuse, you can put them into a module. That module can be mixed into many classes, as long as you make clear what does the module expect from the classes that you're mixing it into. If you want to reuse implementation, then you'd use the traditional thing. Classes have ancestors, they have subclasses, and as we'll see, contrary to what you might think coming from the Java world, remarkably often, what you want is the first one. You don't want to reuse implementation, you want to define behaviors and reuse them.